Straight lines. So this is our next topic. We're looking at, starting off, we're going to look at the slope. And the slope really is just talking about the steepness of the line. We usually use the letter M for slope. And the slope can be 4 different things. So again, the steepness, it tells us. So in a business application, we could think about it, if I have revenue and it's a really good revenue problem, a very strong revenue problem, that means I'm bringing in a lot of money. I can demand a lot of money for whatever product that I'm selling. So again, we use the letter M for slope, and it's a ratio. And the ratio is change in Y over change in X. This delta notation means change, and you'll see it not only in math classes, but you'll see it maybe in your chemistry course or other classes. And if I'm given 2 points, we can find the slope by subtracting the y's, so that's that change in y on top, and subtracting the x's, which is that change in x on the bottom. So like I said, there's 4 different things that can happen when we talk about slope. I could have a positive slope. So if my line has a positive slope, as I move from left to right, then it's increasing, it's going up. I could have a negative slope. And in that case, as I move to left to right, the line is going down. I could have 0 slope. Let me use another color for this. As I move to left to right, nothing's happening. There is no change. So that's 0 slope. And then lastly, I can have an undefined slope. And it doesn't move to left or right at all. It just goes straight up and down. So how does that, especially these last 2 cases, relate to this? 0 slope means the y's never change. And you can see as it goes straight across, the y are always the same. Whereas undefined, x never changes. And so you get a 0 division by 0, which we know is undefined. So that's why we call that slope undefined. So there's no movement at all from left to right for that. So let's just find the slope given 2 points. So I have the point -1, 1, and 5, 3. And it doesn't really matter which one you call x1, y1 and which one you call x2, y2. It's just the point is you have to be subtracting the y's on top, the x's on the bottom, and they have to line up underneath each other. So whatever one you call the x2, y2, if you have y2 on top, then that coordinate that's in the ordered pair has to go right underneath it. So I'm going to do 3 minus 1 on top, 5 minus a -1 on the bottom. So I get 2 over 6, and that has a slope of 1/3. And just one more. Let's do 1, 7, 1, -3. If I want to find the slope of this, again on top, I'm going to do -3 minus 7. And on the bottom, I get 1 minus 1. So I get -10 over 0. And because we can't have division by 0, this slope is undefined. Some basic principles. We can tell if lines are parallel, if their slopes are exactly the same. So if I had a line y equals x, that line would just go right through the origin. And if I have a line y equals x plus 2, it's going to cross the y-axis at 2. So the slopes are exactly the same, and these lines are parallel. Both of these have a slope of 1 because that number in front is where you'd find the slope. So we're going to talk about slope-intercept form in a second. But before we do that, we talked about parallel lines, and then we also have perpendicular lines. And these cross at 90-degree angles. And how can we tell? They're going to be opposite and reciprocal. So one way that people write it is m1 equals negative 1 over m2. But if you just multiplied both sides by m2, another version of this would be m1 times m2 equals a negative 1. The only exception for seeing if these are perpendicular is if I had a horizontal and a vertical line, because then I'd be multiplying 0 by undefined, which you can't really do. But if I know if I have one line that's straight up and down, the other one that's going straight across, those are also going to be perpendicular lines. So, for example, if my first line had the slope of 2, a line perpendicular to that, I'd have to do the negative and flip that over. So a line perpendicular would be negative 1/2. Alright, so let's talk about the slope-intercept form, which is probably used the most, what people are most familiar with using, and that's the form y equals mx plus b. M, we're always going to use that for the slope, and this b is the y-intercept. So the line I did for parallel, when I had the y equals x plus 2, I knew that it crossed the y-axis at positive 2. So just to write that out, the slope was 1 because there's no coefficient, so it's understood to be a 1. And the y-intercept, written as an ordered pair, would be 0, 2. So that's slope-intercept form. Another form that you may not be as familiar with is point-slope form. And point-slope form, y minus y1 equals m times x minus x1. So this form doesn't tell you what the y-intercept is, like slope-intercept form did. The slope is still going to be in here, but this x1, y1 could be any point on the graph. But if you take it and simplify it, then you can get it down to slope-intercept form. So x1, y1 is just any point on the graph. So for example, if I have y minus 7 equals 6 times x minus 2, then this point, remember these are subtracted, so the point 2, 7 is just a point on the line. And the slope of this is equal to 6. And then the last one that we'll talk about, the last form, is standard form, which your book really likes. So a lot of your answers are going to have to, when we get into it, they're going to have to be written like this. It's ax plus by equals c. Ax plus by plus c equals 0. And there's a few things. A has to be positive, so a is greater than 0. And a, b, and c are integers. So if there's any fractions, you have to multiply through to clear it out to make sure that a, b, and c are integers when you write it in standard form. And then lastly, we talked about the vertical and the horizontal line. So the horizontal line is just y is equal to b, because there's no change. Remember, those were just straight across. The slope was 0. So if I had y equals 2, and that would be that line. And then a vertical line it's just x equals something. The slope was undefined. So if I had x equals -1, I would just find -1, and it's straight up and down. It doesn't move at all as you go from left to right.